In this video, we're going to take a look at an introduction to radicals. And to do this, we're going to start off by looking at what are called perfect squares. So this should be a little bit of a review of previously learned material. But for each of these, we're going to find the square root of the numbers. So if we're talking about the square root of 4, we want to know what number times itself would give us 4. So then the square root of 4 would just be that number, which in this case is 2. Same with the square root of 49, we're going to make that 7. This would be 9, 13. Square root of 64 is 8, and 5, and so on. Again, we're just looking for the number that multiplies it by itself to give that number underneath that square root symbol. And so these are numbers that are going to show up pretty frequently. We want to make sure that we're very familiar with those, especially when we look at the next video on simplifying radicals. If we know these perfect squares, it makes our job a lot easier. So when we look at an activity like activity 1, the first thing we want to do is look at some vocab. So the symbol that we have here, that square root symbol, we call that a radical. And to simplify a radical means we're going to take out any perfect squares that are in there. And if it is a perfect square that there's no other numbers inside, that's ideal, but that's not always going to happen. The number beneath that radical symbol we call the radicand. So in the expression right here, we've got that 144. That number underneath the square root is called the radicand. And same thing with the 3, because that 3 is underneath the square root. That is the radicand. So in number 1, identify the radicand for each expression below. So again, 81 is the number underneath the square root, 37, 49, 6, 144, and so on. Just identifying the number underneath. So the point of that, though, is to take a look at what are called rational numbers versus irrational numbers. An irrational number, by definition, is a number that can be written as the quotient of two integers. So quotient meaning division, fraction, ratio, all equivalent. So if we look at the column there where we have rational numbers, we have 17, we can write that as 17 over 1. The square root of 49 is just 7, so that expression right here becomes 7 over 2. Negative 4.3 means negative 4 and 3/10, so we can make it negative 43/10, and so on. All of these are rational numbers. An irrational number is just the opposite. It's a number that we can't write it as the quotient of two integers. Square root of 71, 2 root 6, square root of 46, all of those will not simplify to perfect squares. So our goal then here is identify each number below as rational or irrational. If we need to, we're going to refer to the warm-up. So what I've noticed when I did this is these numbers right here all of those are rational numbers. Because if I take a look at the radicand, again, that's the number underneath the square root, every single one of those is a perfect square. 81, 49, 144, 64, 121. So what ends up happening is if I find out what the square root of 81 is, I just get 9. I can write 9 as 9 over 1. If I take the square root of 144 over 2, I can write that as 12 divided by 2. That's a rational number. If I have this number here, 6 root 64, I can write it as 6 times 8. That's 48. We can write it as 48 over 1. So all of these are rational numbers because the number underneath the square root, the radicand, is a perfect square. The rest of them are irrational numbers. Even if I were to simplify them, which means take out any perfect square factors, which on these I cannot, but if I were to do that, I would still have numbers in the radicand. There'd be no perfect squares completely out. Okay, so let's kind of put this together and take a look at a couple of these problems. Let's just do a few. First says identify the radicand. So we've got 100. And classify the number as rational or irrational. So we're taking 2 times the square root of 100. We know the square root of 100 is 10, so that will turn it into 2 times 10, which is 20, and so that would give us a rational number. On 18, we have 26. 26 is not a perfect square. So if I were to try and simplify that, I would still have numbers left in the radicand that would leave an irrational number. The numerator and denominator would not both be integers. Let's go with number 24. I think number 24 is kind of a tricky one. We got the square root of the fraction 9 over 4. So another way to think of this, because it's the square root of that whole fraction, is I could essentially break it down to this. The square root of 9 over the square root of 4. So the square root of 9 we know is just 3, and the square root of 4 we know is just 2. So the radicand, again, just the original expression, what was underneath the radical, is 9 over 4. But when we simplify that down, we end up with 3 over 2. That is totally a ratio of two integers, so that is a rational number. And in this activity, we're looking at what happens when we multiply and divide. Because it's not just a matter of, okay, we have one number and that's all. We're going to actually be able to multiply radicals together, and same thing with division. Well, take a look at number 1. In number 1, we have 3 root 5, 2 root 7. We're multiplying those together. So essentially, we took the 3 and the 2, and we multiplied those. We took the 5 and the 7, and we multiplied those to give us this expression, 6 root 35. And it worked the same for all the other ones. 2 was kind of a cool exception, though, because if you have the square root of 9, we know that better is just 3. So first thing we did is turn that into a 3, and then we can multiply. So when we're multiplying radicals, we're going to multiply the coefficients. Those are the numbers that are on the outside of the radical symbol. And then we're going to multiply the radicands. Those are the numbers that are inside of the radical symbol. Okay? Division is really no different. It's the same basic idea. We're going to divide coefficients and, if possible, divide radicands as well. But again, you want to be on the lookout for perfect squares first. So for instance, number 4, when the square root of 4 is just 2, that makes it so much easier than finding 6 over 4 and trying to simplify that. We want to avoid that. So there's a couple of review problems here. Compute each product or quotient below, simplifying your answer where possible, and identify your answer as a rational number or an irrational number. So we're going to multiply these things together. I'm going to take 3 times 12. Those are my outside numbers, 36. And I take 6 times 5. That's 30. And square root of 30 is not a perfect square. So I know then my final answer then, this is going to be an irrational number. If we did a question like number 3, yeah, I can divide 20 and 6, but I did notice that the square root of 9, that's a perfect square, so I can turn that into 20 times 3, which would give me 60 divided by 6, which would simplify down to 10. 10 can be written as a fraction, just 10 over 1, so that is a rational number. Number 4, we cannot simplify that square root of 3. We just kind of have to leave it there. But there are numbers outside that we can simplify. We can take the 10 and 6 and divide those out to give us 2, and then square root of 3 left over. Now, again, we have a radical left. It's not a perfect square, so that would be identified as an irrational number. Number 5, we have the square root of 36. That's what jumped out at me. I'm going to change that to just simply 6. The 6 and the 2 are on the outside, and I'm multiplying, so I'm going to multiply those two numbers. I get 12, and then my square root of 3 is just there. So there's my simplified answer. And again, square root left over, so that's an irrational number. And then one more, let's look at number 8. On number 8, if we don't recognize that in the bottom we have the square root of 9, it makes things a lot more challenging for us, because 14 divided by 9 is 1 and 5/9, so I'm not really sure what that is as a simplified radical. So much easier if we recognize that 9 is a perfect square, because we can just turn that into a 3. So we have 24 root 14 over 2 times 3, which we know better is just 6. So we've got 24 square root of 14 divided by 6. The numbers on the outside are the 24 and the 6, and we're going to divide those out and get 4 square root of 14. Okay? So again, the idea on these are just look for perfect squares if you can first, and then follow your rules of multiplication and division. Makes things a lot easier. If you have radicals left, meaning that what's underneath the square root, the radicand, is not a perfect square, then we will end up with an irrational number.